let's talk about heat exchangers, whether it's air conditioning, the radiator, the intercooler, the battery. This is not a hybrid, so let's just take hybrid out of the equation right now. We have to stop getting used to these names in the automotive industry of just a unique thing. Oh, that's a radiator, whatever it's called. Okay, let's get it down to what they are. They're heat exchangers. Everyone exchanges heat. So we have a heat exchanger right here. In an automotive, we call this a condenser. We have a heat exchanger right here. It's a radiator for the combustion gas engine. You'll have another heat exchanger off to the side. Now, depending on what vehicle manufacturer you have, look at, we have two of them right here. And on this particular vehicle, I didn't trace down their circuits to see what they go to, but say you had a Porsche, you could have a heat exchanger right here that is for your engine oil. Then you can have another heat exchanger over here that either can be in series loop with the radiator or say the transmission. And actually on this one here, I believe this one could be the transmission, or you can have the power steering heat exchanger. Then the passengers want to be heat in the winter time. You have a heat exchanger under the dash, we know as a heater core. But you want cooling in the summertime, so you have another heat exchanger under the dash called the evaporator. Now, internal combustion engine, ICE as some people call it. Now let's make this a hybrid. Now you have another heat exchanger that you can add for the inverter, the power inverter. Then you can have another heat exchanger all the way in the back where the battery pack is. It could be either direct expansion, DX, where they have a expansion valve hooked up straight to a glycol loop through a plate heat exchanger for glycol in the battery like B&W has, or you can have even another evaporator stuck, let's say Ford, what is that SUV they damn it had, Explorer, whatever, not Explorer, can't remember what it's called, but they have another evaporator back here that is just for blowing air through the battery pack in the rear there. That's another heat exchanger. You also could have like a heat exchanger for, let's use the Fisker for example. They'll have a glycol plate heat exchanger up here off of the compressor before it goes to the expansion valve to the evaporator inside for cooling. They'll have a secondary branch going to another small expansion valve going through a small plate heat exchanger to cool off coolant that will be in a coolant line, that it'll pump the coolant to the battery pack and flow it through square metal tubes that are touching all the battery packs, cooling off the batteries. That's another heat exchanger. Then you get into something like the Tesla and you'll have another heat exchanger. Oh, you'll have say 3, 4, or 5 liquid glycol pumps with 3-way valves diverting cooled refrigerant from the compressor through a heat exchanger to all the different electric components that produce heat to get rid of heat. Then you can have like the Hellcat, you'll have a big heat exchanger for the turbo. You have a turbo intercooler, so you'll have your intake right here, it'll come through, it'll go through a heat exchanger, and then it'll go outside to a filter, another heat exchanger there. But in the Hellcat, you'll even have another heat exchanger for the the intake manifold. So what they do is they put a glycol loop heat exchanger underneath the intake manifold because it's going through, say you have a car with a supercharger or a turbocharger. They make the pressure so high in the intake manifold, when you compress air, you make heat. Well, when you have heat is an enemy to compression and for dense air. So what they'll put is they'll put a glycol heat exchanger under the intake runners. They'll take that compressed, high compressed, and you have 14, 20 psi, 40 psi hot compressed air from a supercharger or a turbocharger, and you want to feed it to the intake valves, but you want a dense mixture of air, because the cooler air is, the more dense, the more air you could pack into a smaller area. So then they'll use that same air conditioning to chill a glycol loop and force it through that heat exchanger under the intake of the compressed air from the turbocharger or supercharger, which they'll have like an electric compressor, electric water pump for the glycol loop pumping it. And there's just so many heat exchangers. Look at the BMW. The BMW doesn't even have a condenser on the front of some of their air conditioned cars. There was a 3 Series and a 4 Series, and I can't remember what the numbers were, but they have a plate heat exchanger directly off the pump, sitting with a short hose going about, say 12-15 inches, and makes a loop from the back of the compressor. It goes right into a receiver dryer and an expansion valve, right into a liquid glycol plate heat exchanger, and it loops the hot air. They have a glycol heat exchanger up here, and what they do is they get rid of the heat out of the hot gas discharge of the compressor, and they inject it right into a liquid plate heat exchanger that goes through a glycol, what you would call a radiator or a condenser, but there's no refrigerant in it. What it's doing is taking that hot gas right off of the compressor directly, a direct shot of hot gas, only traveling a few inches, and it's going into a glycol, going through, getting somewhat subcooled, and it goes back, and there's an expansion valve right there, and it cools it down for the compressor. So you totally eliminated a condenser and all the lines needed for a condenser and anything remote. And there's many more heat exchangers. So the future of cars, which is here now, as you can see, I mean, this is something that you would only see on a Ferrari or a Lamborghini 20 years ago. You would never see anything like this with this many heat exchangers. Only, you know, think of the Ferrari Testarossa, where you had the back vanes back here that went into back here. Well, they had heat exchangers back there, and you had your air conditioning heat exchanger, or you had your engine coolant heat exchanger, or engine oil heat exchanger. So what we see on common everyday American cars was considered the utmost high end on luxury vehicles 20-30 years ago. And that's not all. More is coming. Here in the United States, we're just starting to see heat pumps coming on cars. I really hope they introduce CO2 in the United States market. They have it in the German market. CO2 heat pump systems on cars. Probably won't be the greatest to use in hot places like Arizona or Texas, but I would like to play with it. It would be a monopoly for me because it won't be worked on by the average guy in a shop. I also want to see propane or butane used as a refrigerant going through glycol loop heat exchangers, where they cool off the glycol, say down to 28 degrees or so, 25 degrees, it doesn't matter, and you deliver it metered through pulse width modulation. You can modulate how much cold glycol would go through an evaporator under the dash, and all you would need is 3, 4, or 5 ounces of propane right out here at the compressor, and nothing more other than an electric heat pipe and a plate heat exchanger. It'd be so simple, other than all these freaky people who say the sky is falling and Armageddon's coming because, oh my god, you're going to use propane or butane. Mofo, what are you driving with? You got 15 gallons, 20-gallon gas tank of liquid petroleum gas in your car. You have brake fluid, well, we're getting rid of brake fluid, and transmission fluid that is more flammable than the little spurt of 3, 4, or 5 ounces of natural gas for the refrigerant system, compared to if you catch 12 quarts of transmission fluid and spray it all over the car from a busted line. That thing's gonna go up like no tomorrow, compared to a little poof of a few ounces of hydrocarbon refrigerant as a refrigerant. So get ready for the future, it's coming, and get ready for a lot more heat exchangers and a lot more 3-way glycol control valves and a lot more electronics. This is basically going to wipe out the rest of most of their radiator and air conditioning shops that are still in existence. In the next 10 or 15 years, the ones who do not educate themselves, tool up, and have the intelligent manpower or the owner who can't train his employees to handle this new upcoming generation of heat exchangers. Just like when electronics hit diesels and emissions controls, diesel mechanics and shops closed down all over the country. When there used to be AMCO transmissions everywhere, and then all of a sudden transmissions had electronic controls, a transmission control module with solenoids on it, transmission shops all over the United States closed down in the masses. They were going bankrupt left and right. Remember, there used to be electrical shops that just specialized in electrical, and you take your car if you had an electrical problem. The mechanic down the street who couldn't solve it would send it to Mr. Joe up the street, who was an electrical engineer with a test light and a light bulb and, you know, a shunt resistor, and that's all he knew. But he never graduated to that next level of a lab scope and 5-volt systems and variable, you know, throttle control and stuff like that. All the electrical specialty shops in the United States started shutting down left and right because computers came into the game, and these were guys who just knew you grab an old headlight and that was your 12-volt reference, and that's all you needed to do to test anything on a car. Those old timers, they all closed their doors when electronics come in. I got to see all this come and go. This was stuff my dad told me that was going to happen before he got out of the industry as he was training me. It all happened, and more is happening. So the next wave of putting air conditioning and radiator specialty shops out of business is the different types of heat exchangers and how they are controlled. If you don't understand the circuit and the mode of operation, you will be out of business and shutting your doors. I guarantee it. See you guys later. Bye.